So I'm going to talk about our technology and how that's different from other filter technologies out there. Today I'm going into a microscopic level to try to understand the capturing mechanisms that happens inside a fibrous filter. What is very commonly used in this field of research is something called a single fiber model. So you're basically taking one of the filter fibers inside of your filter, you cut it in half and you're looking at it from the side, and it looks something like this. Of course, coming into this filter fiber and into this filter is airflow. Approaching the fiber, the airflow wants to go around the fiber and out to the other side. So the flow pattern looks something like this. If you have a very large particle entering the airstream here, and the diameter of that particle is larger than the distance between the fibers in the filter, it's going to be caught like in a sieve, and that mechanism is called sieving. Easy to remember. The second capture mechanism is when you have particles approaching the filter fiber and they're right here in the middle of the flow pattern. It's not going to deviate and follow the airflow around, it's going to be caught right in the center of this fiber. That is called direct impact. As particles get smaller, they're placed somewhere else in this flow pattern, a little bit to the side of the center here, coming in towards the fiber. They want to follow, of course, the airflow around the filter fiber. But when the particles are still large enough so that they have a mass and they're heavy, they still have an inertia, meaning that they're not going to exactly follow the airstream around. They're going to deviate from the airstream and still hit the filter fiber instead of just passing around it. And that capture mechanism is called inertia. And now, talking about really small ultrafine particles, something very interesting happens. That is that the particles are so small that they start behaving almost like gaseous molecules. If you remember chemistry or physics, that means they're bumping off of each other, and if you heat a gas, they're going to bump even faster, and so on. So the particles coming into this airflow is bumping off of each other and other molecules, and they can go almost anywhere. They have a lot of also vertical movement, not only horizontal. And that means moving large distances like this through a fibrous filter, there's a very high probability that it's going to touch one of the fibers going out. So this capture mechanism is normally called diffusion. So this, when you're looking at a mechanical filter, are the four main capturing mechanisms. What's interesting about Bissell and what we're able to do is we're adding on a fifth force. What we do to the particles coming into the airstream here is we're giving it a negative charge before it enters the filter. It's an internal process within the air purifier. We use a special polymer inside of our filters. It has a very special ability to polarize itself. So in the presence of a charged particle,